Hello, my fellow mathematician. Welcome to the study of exact differential equation. We are considering this equation given here, bracket 4xy plus, this is plus 3y squared minus x, everything dx, then plus x squared plus 2xy, everything bracket dy is equal to 0. So first of all, we are going to write function of m, which is in terms of x and y. The part where the x is that function which is 4xy plus 3y squared minus x. Then once we have this function, we get dm over partial derivative of m with respect to y. In this case, we are going to get 4x plus 6y. Then from there, equal to x squared plus 2xy. Plus 2xy that way. Then we find the partial derivative of n with respect to x. In our case, it will be 2x plus 2y. Once you have that, the next thing which you do is that you compare partial derivative of m with respect to y. In our case, it is not equal to partial derivative of n with respect to x. That means that our equation not exact. Our equation it is not exact. So when your equation is not exact, there are 3 rules which can be employed to make our equation exact. And this is the rule we are going to apply here. The rule which tells us 1 divided by n into bracket partial derivative of m divided by partial derivative of y minus partial derivative of n divided by partial derivative of x, close the bracket. This should give you a function of x. Then we are going to substitute. We substitute in that formula 1 over our n is x squared plus 2xy multiplied by our partial derivative of m with respect to y. We have found it to be 4x plus 6y minus partial derivative of n with respect to x. We have found it to be 2x minus 2y. We do it that way. Then we simplify. So this is 1 over x squared plus 2xy multiplied by, here you have 4x minus 2x. This will give you 2x plus you have 6y minus 2y. This will give you 4y. This can be written as 1 over, we factor x on this denominator to be left with x plus 2y. Here we can factor 2 out, bracket 2 into bracket x plus 2y. You can see what is in the bracket can cancel, plus 2y that way. So this part in the bracket can cancel, and then we are going to be left with the 2 over x. 2 over x, that is what we get. Then the next thing now, it is we get what is called integration factor, which is found by exponential integral of f of x dx. We substitute, which is equal to exponential integral of 2 over x, which is the same as exponential natural logarithm of x. After integrating 1 over x, it is that, which is the same as exponential natural logarithm of x squared. This is equal to x squared. That is equal to x squared. Now, once you get your value of x, the next stage now, you multiply your given OD with the integration factor. Our case, it is x squared. And when you multiply, we are going to obtain the following. So we are going to obtain 4 x cubic y plus 3x squared y squared minus x cubic everything. This is our dx plus bracket x power 4 plus 2x cubic y. This is dy, which is equal to 0. After multiplying our given ODE with the integration factor, then the next thing now we check whether now this one has become m is a factor of x and y, which is equal to 4x cubic y plus 3x squared y squared minus x cubic. Then we get partial derivative of m with respect to y, which is equal to, this will give you 4x cubic. That of n a function of xy, a function of xy is equal to x power 4 plus 2x cubic y. Then we get partial derivative of n with partial derivative of x. Here we are going to get 4x cubic plus 6x squared y. Once you get that, the next thing that you do now, you compare partial derivative of m with respect to y, which is equal to partial derivative of n with respect to x. In our case, we have obtained to be 4x cubic. This is plus, derivative of n over x. It tells you that our equation is exact. So now, since now our equation has become exact, that means that that equation, we are going to seek the solution of this form f of xy, which is equal to c. And from this one, the total derivative, is partial of f with respect to x dx plus partial of f with respect to y dy is equal to 0. Then, this is what we are going to employ in the next stage to solve our differential equation. That means that partial of f with respect to x is equal to 4x cubic y plus 3x squared y squared minus x cubic. Then you can multiply by partial of x in both sides, 4x cubic y plus 3x squared y squared minus x cubic, everything partial of x. Then we integrate this equation both sides. When you integrate and differentiate, you are going to get a function of f of x, f of xy, which is equal to, this one we are going to integrate term-wise. So when we integrate x cubic, it will give us x power 4 y divided by 4. This 4 will cancel, plus x power 2 integrated will give you x power 3 divided by 3. So this 3 will cancel, y squared minus 1 over 4 x power 4 plus a function of y. That way, then from, you can call this equation 1 for the purpose of the substitution which we will make. Then you differentiate equation 1 partially with respect to y to obtain the following. So here we will obtain x power 4 plus 2x x cubic y plus g of y prime. So that is what we obtain. After obtaining that, we are going to compare it with the given equation, which was, we compare it with what we are given. We are given partial of f with respect to y is equal to x power 4 plus 2 x cubic y. So when you compare this equation here, you can call this equation A, and this other equation here, we can call it equation B. When you compare equation A with equation B, the left-hand side of equation A, this is equation A, and that of equation B is equal. So you are going to create the right-hand side. So we shall have x power 4 plus 2x cubic y plus g prime y of y is equal to x power 4 plus 2x cubic y. Now, you can see x power 4 is the same both sides, so you can cancel it. And also 2x cubic y is the same, so that now we'll be left with g prime of y is equal to 0. Then from there now, we integrate g prime of y both sides. So when you integrate g prime of y, you are going to get g prime of y is equal to constant c. You call this 2. Then from there now, you substitute 2 in 1. Equation 1, we have f of xy is equal to x power 4 y plus x cubic y squared minus 1 over 4 x power 4 plus constant c. If you want, you can check your working to see whether it is correct, whereby you get f of x, which will give us here 4 x power 3y plus 3x squared y squared minus x power 3. Then you get f of x with respect to y, which will give you x power 4 plus 2x cubic plus 2x cubic y. Then our equation was of this form: df of dx dx plus df of dy dx dy is equal to 0. So, which we have obtained here 4x cubic y plus 3x squared y squared minus x cubic. This is dx plus x power 4 plus 2 x cubic y dy is equal to 0. So after checking, our solution owns, meaning that our working is correct. So thanks so much for taking your time to study with me. For more such working, check in my YouTube channel so that we may continue learning together. Bye bye. See you in the next video as I give you more examples.